Hey guys, so this is part 1 to a 3-part video of sinusoidal transformations. So first we're just going to start with an easy base function, which is the sine graph, and we're just going to start with the very simple y equals sine of x, and just reviewing the periods and increments and amplitudes and shifts for just the basic sine graph. So when it comes to a period, we're always going to use the formula 2 pi over k. So that's going to determine the period. And we're going to be able to find k by looking at the coefficient next to x. So here we can see that there's an imaginary coefficient of 1, so we know that the period is going to be 1. Okay, so we know that k is 1, so we have 2 pi over k equals 2 pi over 1, which equals 2 pi. So we know that our period is going to be 2 pi, which makes sense because it's a regular sine graph, and as we know with the unit circle, we know that all the way around here, this is pi over 2, this is 3 pi over 2, and this is 2 pi. So we know that a full rotation around the circle is going to get us to 2 pi, which means that if nothing's affecting the x, then we're going to be able to do a full rotation around the unit circle. Okay, so now working with the increments. So because there are 4 places that the sine graph is going to go to, so there are 4 either max or mins, we're going to divide the period by 4. So we're going to do 2 pi over 4, which also equals pi over 2. So when we draw our graph, we're going to have the graph increment by pi over 2. Okay, now the amplitude is going to be this imaginary thing right here, which we can put a 1 here because there's nothing there. So we know the amplitude is going to be 1. So our max and mins are just going to be 1 and -1. So very simple. And then our shifts, we obviously don't see any shifts over here, and we don't see any next to the pi. So next to the x. So we know there are going to be no shifts. Okay, so now actually graphing it. I'm first just going to draw a line. So this is what I usually do before graphing it. Before actually drawing an x-axis, I usually just draw a line. And I usually start with whatever shifts we have right and left. And since there are none, I'm just going to draw a 0. Okay, and then I know that we're incrementing by pi over 2. So I'm just going to go to pi over 2. And then pi, 3 pi over 2, 2 pi. And then I usually like to do 2 rotations. So I'm going to go backwards. Negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. So now I can draw the x-axis, the y-axis, and now we can start graphing. So we already know our periods, so we don't really need to worry about that because obviously we have 2 periods from here to here and from here to here. So now we can just worry about first the amplitude. So we know that it's going to go up to 1 and down to -1, as you can see with our amplitude of 1. And since there are no shifts, now we can get started. So because it's the sine graph, we're going to start at 0. So our base point is at 0. And as we know by the unit circle, so I'm just going to draw it real quick. So we know that it's going to start at 0. And then it's going to go up, and then this is 1 up here. So we know that the next point that this is going to need to go to is 1. And we know that this is pi over 2 right here. So we know that this is also pi over 2. And then the sine graph is going to go back down to 0, as you can see at our unit circle, at pi. So now we can graph that at pi. And then it's going to drop back down to -1. And this is at 3 pi over 2. So at 3 pi over 2, we can drop it all the way down to -1. And then we know that when it goes back over, it's going to travel back up this way, and it's going to reach 0 again. And this is at 2 pi. So then we're going to go back up to 0. And now we're going to go back the other way too. But as we can see, if we're moving backwards, so we're moving the opposite way around the unit circle, it's first going to go to -1. So you can see this drops down to -1. And then it's going to go back over to 0. So then we can graph this at 0. And then we know that it's going to go back up to 1. So we're going to go back up to 1. And then we know it's going to drop back off at 0. So then finally we're going to graph at 0. Now we can connect all of our points. So basically we're just going to draw this as a continuous function and making sure to hit all the key points here. So basically that's just a simple sine graph for you. And whenever we do transformations, it's always going to stay to this base model. If it's reflected, it's going to look a little different, but for the most part, it's just going to conform to this model. Okay, so now starting with the cosine graph. A lot of things are going to be the same with the cosine graph as the sine graph. For example, the period is still 2 pi because we know that 2 pi over k. Because k is 1, we know that it's just 2 pi over 1, which is just 2 pi. And since it's going to increment the same because the period's the same, so 2 pi divided by 4 is just pi over 2. And the amplitude, because there's nothing in front here, is just going to be 1. And there are going to be no shifts because this is the base graph. So then when we go to graph it, we're going to start at our midpoint at our shift left or right, and since there's nothing, we're going to start at 0, and we're going to increment by pi over 2 each time. So same as the sine graph, obviously. And then we're just going to draw the x-axis right there. Okay, so now the key points here are going to be a little different. So knowing our amplitude, we still have 1 and -1. But in the cosine graph, we're actually going to start out by starting up at 1. Go up at 1. And like we see on the unit circle, at pi over 2, we're going to go down to 0. And then at pi, we're going to go down to -1. And then we're going to go back up to 0 at 3 pi over 2. And then back up at 2 pi. So then it's actually going to be the same thing as a reflection because it's still going to hit 0 at the same points. So basically this is going to be our graph for cosine. So now working with some transformations. We're first going to start with looking at the period. I'm going to write out period. And we know that it's 2 pi over k, but we don't really know what k is right now because we can see that we have this 3 pi here, but we don't know what this is affected by, so I'm just going to rewrite the equation. So y equals -2 sine, and then I'm going to pull out a 3 pi from the x so we can get k. So we know that k is going to be 3 pi. And now we're going to multiply by x, and then we have to pull out a 3 pi from this pi over 2. So we have x minus, and then if you pull out a 3 pi, that's going to give you 1 over 6, and we still have the -1. So now that we know our period is 2 pi over k, we also know that that's 2 pi over 3 pi, which means that our period is 2/3. Now, we know that it's going to be incremented by whatever the period is over 4. So we have 2/3 over 4, which is going to give us 1/6. So we're going to increment by 1/6 every time. And then we know that our amplitude, because there's this -2 right here, we know that our amplitude is going to be 2, which means that it's going to hit the max and mins at 2. And assuming no reflection, which there is, so we'll discuss that later. And then we know that it's going to be reflected. So reflected, so that means that the key points are going to switch at different points, so we'll discuss that later. And then we know that it has a few shifts. So shifts, we know that it's going to shift right 1/6. And we know that it's going to shift down 1. Okay, so now we can begin graphing. So like I said, I always like to start my middle at wherever the shift is. So right now it's right 1/6. So I'm just going to start the middle of the graph at 1/6 because we know that our one period is going to go this way and our other period is going to go that way. Okay, so now we can begin our increments. So we have 1/6, and then we have 1/3, then 1/2, and then 2/3, and then finally 5/6. And going the other way, we have 0, -1/6, -1/3, -1/2, and then, is that it? Yeah, that's going to be it. Okay, so now we can draw our x-axis at 0, but we do need to remember that we need to start at the 1/6. So we do have an amplitude of 2, but we also have a shift down 1. So we're going to start our graph at -1, and then we're going to go down 2 more because the amplitude is 2. So we have -3, and we're going to go up 2 to get our max, so we have 1. So obviously this is a change of 2, and this is a change of 2. Okay, so now that we have those, we can basically begin graphing with just a normal sine function. So instead of starting at 0, 0, we're now going to start at what our 0 would be. So because it's shifted right 1/6, 1/6 is essentially going to be our x coordinate of the starting point. And because sine graphs always start at 0, our basic 0 is going to be at -1 because it is shifted down 1. So we're going to start right here. This is going to be our 0. Okay. Okay, and then because it is shifted, normally sine graphs would go up, but because it's shifted, sine graphs are actually going to go down now. So we're going to go to 1/3 and -3. Go down here, and then we're going to come back up to 0, just following our basic unit circle. And then we're going to come back up to 1 right there, and then we're going to go back down. And we're going to come back down right here. Okay, and then for the other way, we're actually going to go the opposite, remember? So for sine graphs, it always goes the opposite. So normally we would go down here, but because it's reflected, we are going to go up. And then we're going to come back down there. And then it's going to come all the way down. And then back up. So now if we connect all those points, we have going down and up, and then up and down. So basically that's what your reflection is going to look like. Pretty simple. Basically it's going to be very similar to your regular sine graph, just shifted and reflected. So moving on to our cosine transformation, we're going to need to rewrite this one like the last one. So we have y equals 3 cosine, and then we need to pull out a 2 to get our k. 2 times x plus pi plus 1. So we know that our k is going to be 2. So we know that the period is going to be 2 pi over k, which is 2 pi over 2, which is just pi. And then we know that it's going to increment by the period over 4. So it's going to increment by pi over 4. And we know that the amplitude is going to be 3 with no reflection over any axis, which is nice. And then shifts. So it is going to shift left pi, because we can see that from here. And it's going to shift up 1. And that's all we really need to worry about. So now we can start graphing. So I'm going to start at pi, because we're going to start at whatever our shift is. So actually it's going to be -pi. But I'm going to rewrite it as -4 pi over 4, So I like to write it with the same denominator as whatever the increments are. So we have negative 4 pi over 4, and then it's going to be incremented by pi over 4 each time. So then we have negative 3 pi over 4, negative 2 pi over 4, negative pi over 4, and then finally 0. And going the opposite way, negative 5 pi over 4, negative 6 pi over 4, negative 7 pi over 4, negative 8 pi over 4. And a lot of times teachers will just have you write one period, but I like to do two. So just so that we know where our periods are, they're going to be there and there. Right, so we're going to always start at this point right here. So because it is a cosine graph, we are going to start at the max, but we need to figure out where that is first. So we know that it's shifted up 1, so this is going to be basically our 0. And then the amplitude is 3, so it's going to go up 3 more, so it's going to be at 4. Then it's going to go down 3, so this is going to be at negative 2. So we know that our maxes are going to hit 4, and our mins are going to hit negative 2. Okay, so now we're going to, because it's a cosine graph, we're going to start at our max. And then we're going to go down to our 0, which is going to be at 1. And then we're going to go all the way down to our min. And then we're going to go back up to our 0. And then finally we're going to go back up to our 4. Right, and then we can just do the opposite here. Okay, and then we can connect the points. So there you have it. So this is our cosine transformation. So basically those are just some simple sine and cosine, and then cosine and sine transformations. So the next video will be on secant and cosecant graphs, which are going to be very similar to this one, just we're going to use these as our base functions, and then we're going to go from there.